Hey guys, this looks like a fun one. I got a new Numworks calculator and I wanted to know how well does it handle the algebraic February calendar? Is it able to solve each of these in one step? I suspect it won't solve all of them, but I think it might be able to do a good number of them. So right away, I want to try number 12. This looks like the craziest one. The answer to this is 3.75 billion. And instead of doing it on here and then trying to show it to you, they have a free online emulator that is exactly the same thing as the calculator. So that's going to make making this video really easy. So first we're going to go into calculator. We want to do a custom root of 81. So we'll go to the toolbox, hit the nth root, plug in 81, and then up in this box we'll do the nth root of 64, and then in this box we'll do the nth root of 27, and then up here we'll do the power tower of 3 to the 4 to the 0 to the 4 to the 3. It looks exactly right. And then on the other side we need to do this to the power of the square root of 4. It's way up here, but I think it's just doing that to show the order of operations, which is totally fine. And then we want to do that to the nth root of 81, where in the place of this box, we want 24 minus this sigma notation for this sum. And if we go back to the toolbox, go to calculus, we can scroll down here to sigma notation, and it's exactly that. We'll say k equals 1 to 6 of just k. And I wonder if I can change this to n. Okay, that does work. So this is it. Let's see if it gets 3.75 billion. And it does. That is exciting. That's exactly right. I did not expect it to get this one. I didn't think I'd be able to plug this into a handheld calculator and get it right. That's pretty exciting. So let's give this one a green box. And now let's do some other ones. Let's do 8 next. So it'll be another power tower. Let's see if it handles the order of operations correctly. And here it does. That's perfect. And then next, let's do number 10. Let's see how it handles this exponents and radicals. And it does it perfectly. So 16 for sure works. There it is right there. And for 22, can it handle all this trig? And yes, this is the correct answer right here. And if we click up here to these dots, it gives us more information. And here's a beautiful visual of exactly what's happening on the unit circle. It ends up being the sine of 45 plus 30, that's 75. Yeah, that's exactly right. That's pretty cool. And it looks the exact same on here. Next, let's do 25. Can it handle a power tower with an imaginary number? Let's see if it can do imaginary numbers first. Here's I, so it gives me I. Let's try I squared. That's -1. What about I to the 53? That's correct. What about 7 plus I over 4 plus I? It automatically simplifies it and rationalizes the denominator. What about square root of -49? All right, it just says non-real, which is probably good because if a student isn't doing complex numbers, you don't want it to give a value. I wonder if there's a way we can tell it it's a complex number. What if we just say square root of -49 plus 0i? So now I'm telling it, hey, this is a complex number. And it gives us 7i. That's really cool. So this plus 0i is a little hack to switch from real mode to complex mode. I wonder if I discovered something or if that was the intention all along. So now let's do this power tower. 8 to the power of 3 to the power of I to the power of 2 to the power of 4 to the power of 0. And that is the right answer. So the calculation app works really well. Let's try this equations app. And let's try number 1. And it gives the correct answer for number 1. And then for number 2, it gives the correct answer. Next, let's do number 5. And it gives the correct answer. Number 6, correct answer. Number 9, 14, and 15, they're all the correct answer. So it handles cube roots and square roots with variables in the exponents, no problem. Now let's do 17, 18, and 24. And all those are correct. So for 17, it had no problem doing the quadratic in the exponent or looking at all the possible scenarios. Next, let's do number 20, and that totally works. Same thing for number 7. That one's perfect. So now how does it handle nested logarithms? I included an extra set of parentheses just to clarify what I wanted, and it worked perfectly. So now how are we gonna do 4, 11, and 19? These are all comparisons. If we wanna do it in one step, we can do this one minus this one. And if the answer is positive, the first one's larger, and if the answer is negative, the second one's larger. So it didn't do the factorial of a square root, which is totally fine. I think I know what I want to do with that. This calculator has a Python app. It's my goal sometime this month to learn how to write the Python script to solve each of these in one move. I'm excited to see how that works out. If I figure out how to do it, I'll make a video showing you how to do it. I've never had a calculator that does Python before. I'm pretty excited. So my first impressions of this calculator, I absolutely love it. I think a lot of students and a lot of teachers would benefit from having it. Right now, there's a promotion going on where full-time high school math teachers can get a free calculator. It'll give you a chance to try all this out yourself. The link is in the description. How exciting.